Okay, so for the next presentation, I'm happy to introduce Ricardo, Rodrigo, and Salvador Martínez from ISLA-Link. They will present. They will speak about the IONIAN Submarine cable, a new cable system that will be deployed between Greece and Italy. Ricardo, Salvador, this is a very interesting topic for us, and we're really looking forward to hearing what you have to say. So the stage is yours.
Thank you very much, Andreas, and thank you very much to the board of vGRNOG, Mikalis and Kostas. And yes, so this presentation is going to be quite different to what we have seen before. So it's technically not so profound and very down to earth, because we are talking about infrastructure. We're talking about very, very let's say, tangible type of substance. But I think it's interesting, and actually, let me share my screen with you. So, yes. Okay, are you saying it correctly?
Yes.
Okay. So, so we have changed actually the slogan of the presentation, because we are always saying that it's the most advanced and robust connection between Italy and Greece. But we thought that the vGRNOG's slogan was quite appropriate, because that's what we are doing. So we are building an infrastructure that will help evolve and grow Greece's network. So that's the main purpose of this project. And so yes, just a little bit of background. Let me see, I don't know how to change page. Yeah, so just very quickly. So IONIAN is a new link to connect ultimately Athens and Thessaloniki with Milan and Rome in Italy. And from there, of course, once you are in Milan, you can connect to the rest of Western Europe's main hubs. So it's an infrastructure that will be operated as such, and as such, we will be providing only very large capacities. We will be providing TAC fiber for large operators, but also spectrum for more conveniency, because it will give a service that is going to be from pop to pop, and also, of course, wavelengths. Typically, for this type of connectivities, we are talking about 100 gigabit per second wavelengths. So as you can see, well, we are a neutral infrastructure supplier. We are not in the business to address retail customers, corporations, or let alone residential users. Of course, we are only here to serve the needs of operators, all operators, also big consumers of capacity, such as OTTs and other ISPs. So the audience in this forum is quite appropriate for this. And we belong to an investment fund, so we have absolutely no conflict of interest in operating these infrastructures. So we have some history, which I'm going to briefly describe. We started operating in 2001, 20 years ago, with a system that connects the Balearic Islands, which is east of Spain. And so we have a system that with 3 routes that connects these islands to mainland Spain. And then 10 years after, we built a system that connects the Canary Islands, which is in the southwest, facing the north of Africa. You can see it's in orange here. And we have been in the technical development of 2 systems for which we have worked quite a long time. One is the ISLA-Link system that has been just put in service something like a month and a half ago. It's a system connecting Portugal to Brazil, and another one connecting Algeria to mainland Spain. And also we have another branch, which you can see in the north of Morocco, that connects Morocco to mainland Spain as well. So we have already some experience in the field. And now we are working to deploy, IONIAN. So IONIAN is a system that is going to connect, as I was saying, Italy to Greece, and specifically the submarine segment will link the cities of Crotone in Italy with Preveza in Epirus in Greece. But this system is complemented by a terrestrial, quite a substantial terrestrial investment that will build a ring in Italy, connecting Crotone to Milan through Rome and through Bari on the north, and also connecting Athens and Thessaloniki and closing the triangle with the link between Thessaloniki and Athens. So it's going to be a route that has been chosen for the sake of diversity, because you may know it. There are other systems that connect more the north Corfu to Bari, and also one other system that is quite old that connects close to Corfu on the mainland to a city in Italy called Otranto, which is a very short system. And so all these systems are concentrated on that route, on the Adriatic. And so we thought that it was useful for the network as a whole to have an alternative route. This route has been chosen for technical, let's say, basis. So it is unrepeated. So this allows to have a high fiber count, which is important nowadays to go with growth. Also, it means that it is a system that has no active elements under the sea. So this means that the system can last for very, very long, longer than the 25-year standard. And it also allows for operators, users, to have their own fiber pairs if they wish so, and operate them totally independently with their own transmission equipment. So that's a trend in the market. So yes, so it has been chosen to have a distance that is compatible with the fact that it's without repeaters, without amplifiers under the sea. And also we have looked for a route that tries to maximize deep waters. So to avoid having to trench and also to avoid vulnerabilities to the system. So we think that this design is very reliable and it will avoid cable cuts. And so this, together with the fact that on the terrestrial side we have these rings, this protection, we think it's going to be a very reliable, overall very reliable route, offering very large capacity. And now I will hand over to my colleague Salvador, who is the project director and who is going to give you more specific details on the deployment.
Thank you very much, Ricardo. And thank you, vGRNOG, for the invitation. Just a brief explanation of the submarine cable itself. As Ricardo was mentioning, this is an unrepeated cable with 24 fiber pairs. And to maximize reliability, we intend to build and to bury the cable from the landing points in Preveza and Crotone up to 1,000 meters water depth. This is very important because this is the main portion where fishing activities and anchoring can affect and can make outages of in the cable. So in the first 2 to 3 kilometers in the cable, let's say from water depth 0 to water depth 15 meters, we will be using double armor cable. This is the most and heaviest cable in submarine, and this means that It will be protected even with some articulated pipes in the short end. And after 15 meters, the cable is directly buried through a plow, and we could see some pictures after in the presentation after this. And from 1,000 meters, the cable is just laid in the seabed. So it means that there's no risk due to fishing activities. So in that case, we will be using lightweight cable that we will see in the next slide. So overall, the system will be buried around 88% of the route, and will go through deep waters. And the estimated layouts for this cable will be around 3 weeks. Now we are in the process of performing this marine survey in the cable. So the vessel has been doing this job for the last few weeks. And now we are engineering the final route. So this slide here was based on the desktop study done before the route survey. And some changes are possibly coming in the next weeks, but just a few ones. So you can skip to the next slide, Ricardo. So here we have some pictures of different cable types depending on water depth. So as I was explaining before, the double armor cable is used from the beach to 15 meters water depth. This is the most robust one. And then from 15 meters to 1,000 meters, we will be using a single armor cable. The only difference is in the number of wires, protected wires along the cable. And finally, where we have just laid the cable on the seabed, we will be using lightweight protected cable. One important feature of these cables is that there is a layer of copper between the fibers and the protection wires. And this allows to first minimize the hydrogen of the fiber. And this is one of the most important sources of increased attenuation over the lifetime of a cable. And the only existing, the best barrier to prevent this aging of the fibers due to hydrogen is the copper. So these cables will have a layer of copper. But additionally, this will allow us to monitor the cable from the landing station. When you have a repeated cable, you can monitor all the way through the amplifiers in the cable. But when we don't have repeaters, you can only monitor the fiber itself. So that means that if there is a shunt fall in the cable, meaning that the protection of the cable is damaged, but not the fibers, then the water will be coming into the cable. And in the end, when the fibers are affected, you will have to replace a long portion of the cable due to this cable coming in. With this kind of monitoring, we can just understand that we have an outage at the cover of the cable without affecting the fiber. So we can send a repair vessel as soon as possible to repair the cable without the need to replace long length of it. And here on the right-hand side, you can see some pictures of, this is the first one, the lead cable sheet. This is the cable used to lay the cable from Electra. This is the one that will be laying the IONIAN cable. And also you have pictures just for information about how these cables are deployed into the vessel from the manufacturer. And ROV, which is a remotely operated vehicle that is typically used after the cable is laid for final inspection and additional burial if it is required. Next slide. And here are also some pictures of the shore-end machinery used. And this is depending on the seabed conditions, you need to have one or the other. The first picture is an excavator, which is used mainly when you have a rocky seabed, which it is the case of Preveza. So we will have to trench from the beach, and with the maximum water depth of 100 meters. We will have to use a machine like this to trench the seabed and be able to bury the cable in it. On the other side, when we have, for example, in Crotone, when the beach and the seabed is just sandy, we can use a cutting chain or a jetty machine. Normally, we use a jetty machine, which is just a machine that is able to inject high-pressure water to the seabed and building a trench this way, and then we just have to lay the cable over it. Next one. Yeah, just a final technical slide to give you brief information on the timeline of our submarine cable project. For this specific cable, we selected landing points and completed the permit feasibility study and before the end of 2020. And in early this year, we completed the desktop study in route engineering. And recently, we have reached the financial closing, which means the points where we have selected the contractor building the system, but we also have all the funds in place to go ahead with the implementation of the cable. And just at this moment, we are finalizing the marine survey and the route engineering, final route engineering, so we can start with the permit application, which is normally in the critical path of a submarine cable construction. And also we will start as soon as possible with the cable manufacturing. The permitting side will last around 12 months from this point. So we will be able to lay the cable finally after the blackout window, because we cannot lay the cable in Greece and Italy during the summer. So we will have to wait until October next year to lay the cable, commission the cable, and finally we expect to have the cable ready for service by November 2022. Ricardo, you're on mute.
Sorry. Yes, so there's a final slide, which is somewhat redundant with what already explained, because it's about the services, but I think it's interesting to understand what is the kind of connectivity that can be achieved. So there is, of course, capacity, plane capacity, so between two POPs with wavelengths. We have put as an example 10 gigabit, but we expect more to have customers, operators using 100 gigs. Well, it will vary, but both can be done. And we will connect this between the four potential, the four POPs, Athens, Thessaloniki, Milan, and Rome. And from a commercial point of view, that will be in the form of either lease of capacity, so that's a rental, plane rental, or IRUS, which gives you ownership of that wavelength for a long period of time, typically 15 years, and it's normally there's some savings in that. And the same with spectrum. And finally, fiber pairs. We are going to also offer the option for operators to buy their own fiber pairs, but that will be done directly from the cable landing stations. So the two cable landing stations in Preveza and Crotone, and the operators will come with their own infrastructure. And this is it. So there's not much more to be said. It's, as I said, a very, very specific, very down to earth, very concrete type of explanation. And so not as let's say, as complex as what we have seen before. But thank you very much to the participants and to the board of the vGRNOG for inviting us, and we are open for discussions, for questions. Thank you.
Thank you very much, Ricardo and Salvador. Very interesting stuff. Are there any questions? If yes, please press the raise hand button. I already see a question from Kostas.
Hello, Ricardo and
Hello,
Salvador. Although I am not a politician, I really want to thank you very much on behalf of my country for this infrastructure. So if you have a look at the submarine cable map, I could see that Greece is completely bypassed from all major infrastructure. So in terms of connectivity, I believe Greece wanted that and needed that. I really wish you the best in terms of your business plans and your investment. And it is these cables that are actually the heart of the internet. It's not the software, it's not the IP packets or whatever. It is the excavators that you saw in your slides that actually make things work. Having been involved very, very briefly in my current employer with submarine cables, we serve really remote French overseas territories, and we are owners also in a submarine cable, co-owners. I wanted to ask you very briefly, the optical rings, the terrestrial optical links, will they be operated and owned by you? That was the first question. And the other question is, have you finished with the bureaucracy of for the landing of the cable, and have you got the permits for the CLS cable stations?
Thank you very much, Costas, for the question. Yes, regarding the second one, as I mentioned, the permits are in the critical path of each infrastructure project, and it's not different from the submarine cable. And this is where we have to anticipate as much as possible. The point for the landing permits, which are the most challenging, is that you cannot apply for these permits until you have the final route of the cable and the final engineering of the system. And this is something that comes after the marine survey. So this is what we are doing at this moment. We are finalizing the marine survey, and we are finalizing the engineering part, and we will apply for these permits in July this year in both countries. And that will come in parallel at the same time with the permits to build the cable landing stations. So we are already working since beginning of this year to find the best possible land plot in industrial areas to build the cable landing stations, and this is completed. Now we have to go ahead with the construction phase and with the permitting phase. And this is the reason why the cable will not be ready until the end of the next year, even though the manufacturing process of the cable will take only 3-4 months from now. So the point is that we need 10-12 months to have the permits in place before we can lay the cable. It's the most important part. The second question, sorry,
the first one was about the operation of the terrestrial rings.
Okay, for that one, we are building the submarine part on the terrestrial side, which is more than 4,000 kilometers of fiber optic cable. We are relying on existing operators with IOU contract for dark fiber. So that means that we are going to have our own dark fiber during the system lifetime, and we will have our own equipment and our own network over it. We're going to operate the system end-to-end from Milan, Rome to Athens, Thessaloniki. But of course, we are not going to trench and to build new infrastructure, terrestrial infrastructure, because we have 4,000 kilometers left, and this is not feasible.
Thank you. I really wish the best of luck to you.
Thank you very much.
And hopefully we can make a coordinated event with ITNOG, with Italian NOG about that.
Oh, that's a good idea. Also, we'll keep you updated as things proceed, and especially for the landing operations. Maybe some of you will be interested to see how that happens in reality. So witnessing the laying of the cable, for instance, in Preveza.
That would be amazing. From my side, my family comes from an Ionian island. So there is also sentimental sentiment involved into that. Thank you.
Thank you.
I see another question from Michalis. Michalis, please go ahead.
Hi, Ricardo. Hi, Salva. Thanks for the presentation. And as discussed previously, it's very exciting news, the one that you've recently shared with us. And hopefully everything goes as planned, and we will have the new infra available according to your time schedule. I will go with a simple question, since you have been operating such systems in Spain and other areas all over the world. I would like to ask about your experience. How frequent are outages on such systems, and on average, how much time does it take for them to be recovered? Thank you.
Thank you very much. Now, please, Ricardo.
Yes, the fact is there are statistics for this, and to give you just an idea, what we are using as a metric is an average of cable cut every 5 years, but that is by no means our expectation. And the reason for that is in the specific case of a cable, the one we built in 2001 that connects the Balearic Islands, which is similar to Ionia in terms of distance and in terms of laying, we haven't had a single cut in 20 years. So we have tried in as much as possible to have the same type of configuration. And but there are other areas, like for instance the North Atlantic, where the cables have to run for very long distance over shallow waters, facing the coast of Ireland and of course and UK, and there cable cuts are quite frequent, mainly due to man-made hazards, not to let's say natural causes, but rather to fishing, trawling, as Salva explained, and to anchoring. So you cannot avoid. I mean, there are, for some routes you cannot avoid this risk, and you have to repair. How long does it take to repair a cable cut? So that also is not an easy. There's no easy answer. What happens is that cables, they are under maintenance agreements with cable maintainers. Very usually they are in the form of a consortium, and in the Mediterranean there is one such consortium which is the most widespread, which is called MECMA. But there are also some private operators like APMA, which is a private partnership between two providers, Alcatel Submarine Networks and Subcom. And what happens then is that once you have a failure, you have to notify the failure to this maintenance provider. Then it's a long process to have a ship mobilized and to go and fetch the replacement cable in a storage, which is normally located in a port, and from there go to the place where the cut is done, then fish the cable, bring it on board on the two ends, and perform the repair and lay again the cable without any kind of lake on the seabed. So all this process can take normally something like 3 weeks. So that's why you want to avoid this type of failure, because it's not, it's something that happens very, very rarely, but when it happens, it is a long process to get it back in operation. We have some advantage in this specific case, because very likely we will be using MECMA for this cable, and the cable ship that does the repairs is very close to the cable. It's actually in Catania, which is in the east coast of Sicily. So it is that's an advantage, because you can, and the cable depot is also there. So that will shorten the process significantly. But overall, what I have given you is the, let's say, the industry average. Salva, maybe you can correct, because I have dwelt a lot on this and you know better than myself.
No, you're right, Ricardo. Let's say that the average is 2-3 weeks time, but it all depends mainly if there's another repairs in queue when you give the advice to the maintenance company or not, and how far you are from the base of the vessel. So in this case, best case scenario could be 1 week. Worst case, that depends on the cables in queue.
Yes. The worst case is that there is 2 cable cuts at the same time and that you are the second one. So that's the worst case. They have to make first reparation, then the vessel has to go back to port, load the cable, and then go and make the other reparation. There are other repairs, so it can take longer. That's not very probable, very likely, but it can happen.
Yeah, so the best thing is to design and engineer the route the best way possible to mitigate all risk of the cable, and to bury very well the cable at least until the 1,000 meters water depth. So this is very, very important. And if you do things like this, you can avoid, where possible, these outages. And for example, as Ricardo was saying, for the barreling cable, 20 years in operation, no outage yet. So cross fingers.
Okay, thank you. Thank you for your answer.
Thank you.
Are there any other questions for Ricardo and Salvador? I saw a raised hand, but it has disappeared. So I guess not. Okay, so thank you very much once more for presenting at vGRNOG.
Thank you very much for inviting us.
Bye.